Where do we usually look when searching for the greatest mysteries of the universe? Naturally, we turn to the light, to the glow of countless stars, to the explosive brilliance of supernovae, to the swirling structures of galaxies. Light attracts us because it carries information. In many ways, it is life itself. Yet imagine for a moment that the true secrets of the cosmos are not hidden in brilliance at all, but instead lie within absolute, impenetrable darkness. In the vast emptiness between galaxies, where we assume nothing exists, this very blackness may determine the fate of everything. Invisible forces could be deciding where new stars ignite and where eternal night will dominate. To uncover what truly hides in these silent depths, we must step into the most remote and shadowed corners of the universe. If we were to zoom unimaginably far away from Earth, the universe would reveal itself as a colossal and intricately connected structure that scientists call the cosmic web. Picture an enormous intergalactic network stretching across hundreds of millions of light years. Its strands, known as filaments, are composed of gas, cosmic dust, and entire clusters of galaxies. They form glowing pathways along which matter slowly flows. But the cosmic web is defined not only by its luminous threads, but also by the vast empty spaces between them. These regions, called voids, are immense, almost perfectly spherical expanses where the density of matter approaches zero. If the filaments are the crowded metropolitan regions of the cosmos, then the voids are its endless, nearly uninhabited deserts. This structure is not theoretical imagination. It has been confirmed by enormous astronomical surveys, including the Sloan Digital Sky Survey, which mapped the positions of millions of galaxies and revealed a detailed three-dimensional image of the universe's hidden architecture, glowing filaments intertwined with gigantic, unsettling dark cavities. These cavities are enormous, typically between 65 and 80 million light-years wide, and some are extraordinary supervoids, so monstrous that our entire Milky Way would be nothing more than a tiny speck in comparison. At first glance, these voids may appear to be passive regions created merely because gravity pulled all nearby matter toward the surrounding filaments. But this impression is misleading. The emptiness itself plays an active role, concealing one of the greatest mysteries of the universe, the invisible structure that holds everything together. This invisible force is known as dark matter, a form of matter that emits no light, absorbs none, and reflects none. We cannot observe it with any telescope, yet we know with absolute certainty that it exists because of its gravitational influence. Astronomers first realized something unusual was happening when they studied the rotation of galaxies. Stars on the outer edges were moving far too quickly. The visible mass of the galaxy simply wasn't enough to keep them bound in orbit. By all logic, they should have been flung into space like stones launched from a sling, but they weren't. The only explanation was that large amounts of hidden mass were present, anchoring everything together. A useful analogy is reinforced concrete. We see only the concrete, the ordinary matter such as stars, planets, and everything we know, but within it is a hidden framework of steel that holds the structure intact. Dark matter plays that same role on a cosmic scale. According to the Planck Observatory's measurements, ordinary matter makes up only about 5% of everything that exists. Around 27% is dark matter, and the remaining 68% is something even more mysterious: dark energy, which pushes the expansion of the universe to accelerate. This means that 95% of the entire universe is made of something completely invisible. Dark matter creates gravitational channels through which gas flows to form the cosmic filaments and galaxies. And in regions where dark matter was scarce, massive voids emerged. Emptiness is not simply the absence of matter. It is the absence of the invisible framework that defines the structure of the cosmos. And through this emptiness, we sometimes detect faint echoes of colossal cosmic events. These signals reveal the second great anomaly. In 2015, an extraordinary moment changed modern astronomy forever. The LIGO detectors measured gravitational waves, the ripples in spacetime predicted by Albert Einstein decades earlier. These waves were created by the merger of two black holes more than 1 billion years ago. The idea is simple. Imagine the surface of a quiet lake. Throw in a stone and ripples travel outward. The same happens when massive cosmic objects collide. Waves spread through spacetime at the speed of light, stretching and compressing the fabric of the universe. Though the effect is incredibly subtle, highly sensitive instruments can measure these tiny distortions. What these waves reveal is profound. Emptiness is not truly empty. It is a dynamic environment through which gravitational waves travel unhindered for hundreds of millions of years. Even in places without stars, dust, or any kind of ordinary matter, space-time itself vibrates and carries information about long-past cosmic catastrophes. A void is not a dead region. It is a vast arena through which invisible messengers from ancient events race toward us. And yet, discussing voids in general is very different from venturing into the deepest one ever discovered. A place so immense and so dark that it challenges our understanding of the universe. This region is known as the Buddhist Void, or the Great Nothing, the largest, emptiest space known to science. Discovered in 1981, it left astronomers stunned. While charting the distribution of galaxies, researchers came across a gigantic region in the constellation Boötes, where there appeared to be absolutely nothing. Its size is staggering, roughly 330 million light-years across, which is approximately 0.27% of the observable universe's diameter. To grasp its enormity, consider that the Milky Way is 100,000 light-years wide. If the Milky Way were shrunk down to the size of a coin, then the Buddhist Void would be the size of a large city. Thousands of galaxies could fit inside this space, yet almost none are there. Astronomer Greg Aldering once remarked that if the Milky Way were located at the center of this void, humanity might not have discovered other galaxies until the 1960s. Imagine pointing the most powerful telescopes into the night sky and seeing absolutely nothing. No galaxies, no nebulae, no faint glimmers of starlight, only pure, absolute blackness. But even this enormous void is not entirely empty. By 1997, astronomers had located around 60 galaxies hiding within the darkness, scattered like a faint, elongated chain drifting through an ocean of nothingness. Their presence introduced new mysteries. How did they get there? Why are there so few? One theory suggests that several smaller voids merged over time, like soap bubbles joining to form a larger one. The galaxies inside may be remnants of the boundary regions between those earlier, smaller voids. Whatever the true explanation, the Great Void challenges our understanding of cosmic evolution and forces us to confront a difficult question. How much do we really know about the universe? Our journey through cosmic darkness leads us to an unexpected realization. A void is not simply nothing. It is not just the absence of light. It is a fundamental component of the universe. It is shaped by the influence of dark matter. It vibrates with gravitational waves carrying information from events older than the Earth itself, and it contains anomalies so enormous, like the Buddhist Void, that they break our assumptions about how the cosmos should behave. Perhaps the greatest mysteries of existence are hidden not in the universe's brightest places, but in its darkest ones. And understanding these regions of near-perfect emptiness may one day bring us closer to answering the most profound questions of all. How did the universe begin? How did it transform over billions of years? And what destiny awaits it? Sometimes, to discover the truth, you must stop looking into the light and instead gaze into the dark.